Now we'll be seeing another question based on the limit n tends to infinity 1 by n, n square by n plus 1 whole cube, n square by n plus 2 whole cube, plus so on up to 1 by 8n. So how will you solve this? You got to write limit n tends to infinity, the same question. As if you take 1 by n, so for limit n tends to infinity 1 by n, and you got to continue the limits for these all. So what is that? You'll have limit n tends to infinity f of 1 by n is equals to limit n tends to infinity the rest of the all things. What is that? N square by n plus 1 whole cube and plus so on. So for this, as limit n tends to infinity, this will be equals to 0. So that is what we got. And here this is in the form of like you can put summation, as you have see, you have n square by n plus 1 whole cube, n square by n plus n whole cube, and so on. So you got to put that in summation n equals to n equals to 1 to n 1 by n squared by n plus r whole cube. So limit n tends to infinity 1 by n is equals to summation r equals to 1 to n 1 by r by n whole cube. So what is f of r by n? F of r by n is equals to this thing, that is the 1 by 1 plus r by n whole cube. So what will be f of x? If f of r by n is this, f of x will be 1 by 1 plus x cube. So as f, we know that f of x is a constant on 0 comma 1. Whenever f is a continuous function, and we know every continuous function is Riemann integrable, so we can tell that if f is continuous, then f is Riemann integrable, right? Then you'll get this one. So what is that? You have to find what is the formula that you actually have? Limit n tends to infinity 1 by n summation r equals to 1 to n f of r by n is equals to integral 0 to x f of x dx. So this entire thing is the question, and f of x dx. Well, in the previous slide, what is f of x? F of x, we got it as 1 by 1 plus x whole cube. So integration of this gives you 1 plus, like what is x power 1 by 3? That is x power minus 1 by x power minus 3 plus 1 by minus 3 plus 1. So in the same way, instead of like this thing, you have 1 plus x instead of x. So you got to write this, and then you will get this and put the apply the limit, that is from 0 to 1. So this is what the answer that you'll get. So all the questions will be of this type. So you first have to find take out 1 by n because it is out of the summation, and then you have to find this integral 0 to f of x dx, right? Now this question 8 is also same thing, just try it by yourself. Then we'll come to the theorem. The next theorem says, if you have f belongs to r over a comma b, then you have to prove integral a to b f of x dx is equals to integral a to b mod f of x dx. And we already know from previous theorem that if f belongs to r over a comma b, mod x also belongs to a Riemann integrable. So if mod f belongs to a Riemann integrable, its minus mod f also belongs to a Riemann integrable. The minus is outside, it is not in the mod. So we know that minus f of x, like obviously whenever you have a function, its minus value lies, like minus lies between minus 1 to plus 1. So in the same way we have defined this minus mod f of x less than equals to f of x. So basically f of x lies between minus mod and plus mod. So this is what you'll get. What is minus? Like applying integration on all the sides. Integral a to b, integral a to b, integral a to b. So what is this? You'll have minus integral a to b mod f of x dx less than equals to a to b f of x dx less than equals to mod f of x dx. So here, how is that you can write? Like whenever you have, see, you have here minus integral a to b f of x dx, like mod f of x dx, and plus integral a to b f of x dx. So what is that you can write? Like whenever you have mod f of x is sum less than epsilon. So if you remove mod, it will be from minus epsilon to epsilon, right? So in the same way, this also you'll get, that is mod of integral f of x dx is equals to integral of f of x dx. Now moving on to the next important theorem, that is fundamental mean value theorem. So what is the statement? The statement says, if f comma g belongs to R over a comma b and g keeps same sign on a comma b, like whenever this f and g belongs to the Riemann integrable, g also keeps the same sign on in closed interval ab, then there exists some mu. See, whenever there is something, so there exists some mu which lies between the infimum and supremum of f on closed interval a comma b. So how is that will be defining such that integral a to b f of x dx or f of x into g of x dx will be equals to, there exists some mod, so some mu integral a to b g of x dx. So let us quickly look into the proof. So what is that proof? What is that they gave? Given that f comma g belongs to R over a comma b, and g, what is g? See here, g keeps the same sign on ab. Same thing, we wrote that. If g keeps the same sign on a comma b, so either g of x should be greater than or equals to 0 or g of x should be less than or equals to 0. First, now I'm considering the first case, that is g of x is greater than or equals to 0, right? So if g of x is greater than or equals to 0, what is that you'll have? If g of x is greater than or equals to 0, you will be having, and we know that f belongs to R over a comma b, as this is greater than or equals to 0, and you know every Riemann integrable is bounded, so we can tell f is bounded on ab. As this is bounded, it will definitely have infimum and supremum. So how are we writing that? Small m is less than or equals to f of x, that is less than or equals to capital M. So where small m is the infimum and this is the supremum of the function. So as we have g of x now, you got to multiply each and every this thing with g of x. So this is f of x into g of x, and this is less than or equals to capital M into g of x. So again, for these, you got to put integrations on all sides, right? I hope I'm clear till here. Next, moving on to the next slide. So once you get that one, so how will you solve this one? M into integral, as M is constant, integral a to b f g of x dx, which is less than or equals to f of x g of x, which is less than or equals to capital M into integral a to b g of x dx. And we already know what is mu. There exists some mu which belongs to the infimum and supremum. So which either belongs to infimum, that is small m, or the capital M, such that what is that we got? Integral a to b f of x g of x dx is equals to mu integral g of x dx. Okay, I think I'm clear till here. Next, moving on to the case 2. So what is case 2? Case 2 is less than or equals to 0. If g of x is less than or equals to 0 for all x. So if it is less than or equals to 0, obviously mgx will be greater than or equals to, this is greater than, so m greater than or equals to f of x greater than or equals to m. So again, multiplying g of x on all the sides and then taking the integration. So if you take integration, what is that you'll have? C, taking the integration. So as m is out of x, integration is with respect to x. So you'll have m integral a to b g of x dx greater than or equals to integral a to b f of x into g of x, and which is greater than or equals to m into integral g of x dx. So, and we already know what is mu. Mu lies between infimum and supremum of the sequence. So, integral a to b f of x dx is equals to mu integral g of x dx. Now, we will quickly look into the problem, which says, yeah. So, the question is, if prove that 1 by pi is less than or equals to 0 to 1, integral 0 to 1 sine pi x by x square dx, which is less than or equals to 2 pi. So what is the integral? Integral is a equals to 0, b equals to 1. And f of x, what is f of x? This one, 1 by 1 plus x square. And g of x, I'm just taking that as a numerator. So, and we know f of x and g of x are continuous on closed interval a comma b. And what is f and g? F belongs to a Riemann integral. So, and every continuous function is Riemann integral. And we know g of x is greater than or equals to 0. So, sine pi x is greater than or equals to 0. So, now small m and capital M are however supremums and infimums. And m is equals to f of 1 is equals to 1 by 2. And m equals to f of 0, that is equals to 1 by 2. Like from the function, like from f, we are just taking supremum and infimum values from these intervals. Okay. Now, from the previous theorem, what is that we can tell? There exists some mu belongs to small m and capital M, right? So that is what they told. There exists some mu belongs to small m and capital M, such that f of x g of x into dx is equal, this is the formula, right? This is the formula. So what is mu? 1 by 2 comma 1, that is infimum and supremum. I'm taking the entire function 0 to 1 sine pi by x by x. So and this will be like mu into 0 to 1, like you have to substitute this one. Okay, I'm just substituting it in the formula. What is that? You'll get mu into minus cos pi by x, and then just apply the intervals. You'll get mu by minus mu by pi into minus 1 comma minus 1. So you'll have minus 2 into minus mu. So you'll have this one 2 pi 2 by pi mu. So what is mu? We want the mu value. What is mu? Mu equals to pi by 2 integral 0 to 1 sine pi x by 1 plus x square into dx. Okay. Now, but what is mu actually? It is from 1 by 2 to 1, right? It is from 1 by 2 to 1. So mu is lying between 1 by 2 to 1. What is mu from the previous slide? This entire thing, right? Pi by 2 integral 0 to 1 sine pi x by 1 plus x square into dx. So just sending this pi by 2 on the other side. So you'll have 2 by pi, 2 gets cancelled. This is 2 by pi. So 1 by pi less than or equals to 0 to 1 sine pi x by 1 plus x square into 2 by pi. Okay. Now the next problem is in the same way. Just try this one. If you do not know, please comment below so that I'll explain it to you. Next, coming to this problem also you can try. It is very easy. Yeah. Now coming to the next theorem, or you can, take it in any way. So a function f on closed interval a b is called step function. Okay, there is some step function. If there exists a partition P, how will we define partition? Normally x naught. So here just we are taking y naught, u naught, u1, so on up to un equals to b of closed interval a comma b, such that f is continuous on each interval uj minus 1. Normally, what is the r subinterval? Xr minus 1 comma xr. So instead of r, we are just taking j over here. And they're asking, say f of x is equals to cj for x in uj minus 1 comma uj. So show that step function f is integrable and integral a to b f, and also evaluate the integration. So they're just telling us to evaluate. So we'll just take the normal conditions that we have. What is that? They give f is a step function. Okay. And on where is it step function? Closed interval. And then we have to define the partition, then the nth subinterval, that is here the jth subinterval, where cj is a constant. And obviously we will be defining supremum of f and infimum of f. So what is the interval? Uj minus 1 comma uj. So delta j, what is the delta length of the interval? So mj is equals to cj and small mj is also equals to cj. And you know what is that? UPF and LPF. So in the same way like earlier what we have done in UPF and LPF, but here you got to find for UFP, like UPF or UFP both are fine. So if you subtract UPF minus LPF, obviously 0. So this will be less than epsilon. So we can tell that f is integrable on closed interval a comma b, right? So next, coming to this, what is that integration? Integral a to b f. So how can we write this? We are just writing it as summation of the integral. Okay, so integral a to b, I'll just write it here. What is that you got? Integral is equals to summation of the integral. So this is integral a to b f is equals to summation of the integral, that is cj, right? So what is integral a to b f? That is summation. Summation is summation j is equals to 1 to n cj into x. What is x? That is uj minus 1 to uj. So just substitute this here. So that is you'll have like applying the integration actually. Summation cj into uj minus 1 comma uj. That is what they just asked. Okay, this is just simple one. And then you have post-state stamp function. So what is post-state stamp function? We'll just look into it. So post-state stamp function is denoted by p of x, and it is defined as px is equals to a, px is equals to a plus b if x lies between 1 to 2, and px is equals to a plus 2b if x lies between 2 to 3. Px is equals to 3 plus b if x lies between 3 to 4. So basically p of x is equals to a plus nb, where x lies between n and n plus 1. Okay, so you just have to substitute. We'll just look into one problem which says evaluate the integral 0 to 4 p of x dx for the post stamp function. So as you have 0 to 4, what is that you have to take? 0 to 1 plus 1 to 2 plus integral 2 to 3 plus integral 3 to 4. So you got to take all these. So what is p of x? Like if you have integral 0 to 1, what is integral if you have integral 0 to 1? So what is p of x? It is just a. What is p of x? A. P of x, if it lies between 1 to 2, it is p, a plus b. So in the same way, you just have to substitute that one. So if it is in between 0 to 1, it is a. If it is from 1 to 2, it is a plus b. If it is from 2 to 3, it is a plus 2b. So if it is from p plus p of x is equals to a plus nb, where x lies between n to n plus 1 or some, yeah, n to n plus 1 or something. So just integrate all these things. So what is that you'll get? Here x, that is 1 minus 0. Here also you'll get x, that is 2 minus 1. Here also you'll get x, that is 3 minus 2 and 4 minus 3. So at the end, what is the answer that you got? 4a plus 6b. Okay, coming to the next question. Yeah, so in the question they gave this one. Integral minus 2 pi to 2 pi x square sine power 8 into e power x dx, which is less than or equals to this one. So what is that we have to find? Take f of x. What is f of x? This thing. X square sine power 8 e of x. So we know x square is continuous, sine x is continuous, and e power x is also continuous on R. That is Riemann. So x square sine x and e power x are continuous on minus 2 to 2 pi, and obviously it will be continuous, like the multiplication also will be continuous on minus 2 pi to 2 pi, and we know f of x is Riemann integrable. Why? Because every continuous function is Riemann integrable, and we also know this one, that is mod of the integral is less than or equals to integral of the mod. So just substitute that in this thing. So what is that you'll get? You will be getting yeah, after the substitution, what is that you'll have? Integral minus 2 pi, 1 second, yeah, integral minus 2 pi to 2 pi x square sine power 8 e power x into dx. So this will be less than or equals to integral minus 2 pi to 2 pi mod x square into mod sine power 8 e power x into dx. So as we are doing with respective to this thing, this entire term will be equals to 1 because the integral is from 2 pi to 2, minus 2 pi to 2 pi. So sine will be equals to 1. And what is that you'll have? You'll have x square. So what is x integral x square? X cube by 3. If you substitute 2 pi, you'll have 8 pi cube by 3 plus 8 pi cube by 3. So what is that you'll have? 16. 16 pi cube by 3. Okay. And in the same way, just calculate these questions and then evaluate integral minus 1 to 3 x and then minus 3 to 2. And then the following, evaluate even these all 4 questions. If you have any doubts, just comment in the comment section. Next, coming to the mean value theorem for integrals. This is a very, very, very important theorem. So what does it say? Mean value theorem for integrals. Earlier we have done mean value, that Rolle's mean value theorem for differentiations. Now here we are trying it for integration. So what is the statement? If f is continuous on closed interval ab, then there exists c belongs to a comma b, such that integral a to b f of x dx is equals to f of c into b minus a, or f of c is equals to 1 by b minus a integral f of x dx. Okay, now looking into the proof, what is that they gave? F is continuous. Write down that f is continuous on closed interval a comma b. F is continuous on the closed interval f is continuous on the closed interval a comma b, and then every continuous function is bounded. So this step comes from theorem 4. There is a statement. What is that? If f is bounded on a b, then f is Riemann integrable. You got to write that proof. And then this one, like earlier we have done this, integral a to b f of x dx is equals to mu of b minus a. So I'm just taking this mu as f of a where c belongs to a comma b. So integral a to b f of x dx is equals to f of c, like this one. C function is f of c. So f of c into b minus a. I'm just substituting this f of c value, that is mu is equals to f of c value there. So what is that? You'll have integral a to b f of x dx is equals to f of c into b minus a. Or you can write this as f of c. You want f of c value, so send b minus a that side. So what is that? You'll have a to b f of x dx is equals to 1 by b minus a. Sorry, what is that? You need f of c into b. So what is that you want? F of c will be equals to 1 by b minus a into integral f of x dx. So you need the value of f of c. That is what you got to prove. Next, moving on to the one problem, like you'll have a more clear idea if you just see this problem. So what is that? It says if 1 by 4 is less than 0 to 1 by 4, dx by root 1 minus x square is less than something. So just take f of x from this. What is f of x? F of x is equals to 1 by root 1 minus x square on 0 comma 1 by 4. This is what the question is. And obviously this is a single valued well defined function on 0 comma 4. That is, if you put 0 in place of x, you'll have a well defined function. If you put 1 by 4, that is also you'll have a finite well defined function. As it is a single real valued well defined function, obviously f is continuous, right? Where on the interval 0 comma 4 by 2. How did we take 0 comma 1 by 4? Because the integral is lying from 0 to 1 by 4, right? So by mean value theorem, what is the mean value theorem? F of c is equals to 1 by b minus a integral f of x dx. This is the mean value theorem. So there exists c belongs to 0 comma 1. What is the integral? 0 to 1 by 4 f of x dx is equals to f of c into 1 by. Like you got to write it in this form. So what is f of c? F of c will be equals to like you got to write this one, 0 to 1 by 4 f of x dx is equals to 1 by 4 into root 1 minus c square. And what is c? C belongs to 0 comma 1 by 4. So I'll just write it a bit more clearly. So what is that you have? You have c is lying between 0 comma 1 by 4, right? So 0 less than c less than 1 by 4. If you square on both sides, you'll have 0 less than c square less than 1 by 16. So if you have like if you put minus, you'll have 0 which is greater than minus c square, which is greater than minus 1 by 16. So put minus, you'll have 1 greater than 1 minus c square, which is greater than 1 minus 1 by 16, right? So this will be 1 greater than 1 minus c square, which is greater than 15 by 16. Now put roots on all sides. Root 1 will be 1. 1 is greater than root 1 minus c square, which is greater than root 15 by 4, right? Again put 1 by, like I'm just continuing this step here. If you have 1 by, see this step, 1 is less than 1 by root 1 minus c square less than 4 by 15. So just multiply, like divide with 1 on both sides. So what is that you'll have? You'll be having 1 by 4 is less than 1 by 4 into root 1 minus c square, which is less than 1 by root 15. So what is this one? 1 by 4 is less than integral 0 to 1 by 4. That entire thing is f of x into dx, which is less than 1 by root 15. What is f of x? In place of c, just put x. So you'll be having 1 by root 1 minus, you'll be having 1 by 4 less than 0 to 1 by 4, the last step. This is what the required answer is. In the same way, you can try it like by applying mean value theorem, then find the integral. You can write this. And the next theorem is, even this you can get it for short. This says if f and g are integrable on closed interval a comma b and f of x is less than or equals to g of x, for all x belongs to AB. So they are just asking us to prove integral a to b f of x or f, the function f is less than integral a to b g. So they're just asking f is less than or equals to b with integrals. What is that? They gave f and g are Riemann integrals on closed interval AB. And if f and g are Riemann integrals, g minus f will also be the Riemann integral on a comma b, right? The next step we know that. But what is h? I'm just taking h as g minus f. Okay, where h also belongs to, like if g minus f belongs to r, f also belongs to r. So I'm just writing this as, see, L of h equals to u of h. That is normally like the Riemann integral. What is that? You'll have LPF and UPF. So instead of UPF and all, I'm just putting it in form of h. So what is that they gave? They've already given that f is less than or equals to g. So f is less than or equals to g for all x, and g of x minus f of x is strictly positive. So what will h of x, if g of x is positive, h of x will also be positive. And what will LH be? LH of p also will be positive, and h will also be greater than or equals to 0. So from these 2 and 3, what is that? This one and this one. What is that? You can conclude integral a to b, h is however positive. But what is h? Integral a to b, g minus f, it is greater than 0. So integral a to b g minus integral a to b f is greater than 0. Send this f that side. So what is that? Integral a to b g is greater than integral a to b f. So if you take this in a correct order, that is a to b f is less than integral a to b g, right? And less than or equals to or greater than or equals to. Okay. Next, after that theorem, you have another important theorem. That is, let f be a bounded function on AB, and un and b un and ln of upper and lower Darboux sums. So I just gave you a note point about Darboux conditions. Just go through that. Then they're asking us for, such that un minus ln is equals to 0. Then show that f is integrable and integral a to b f is equals to limit un and limit ln. So for this, what is that? First you have to take, and then after that you have this theorem. This is the last theorem of your chapter. So let's just look into this theorem. So what is that they told? They just told us, what is that they gave? F is bounded function on AB, and what, and the extra conditions also they gave. What is that? Un is equals to uf comma p, ln is equals to lf comma p, and limit of un minus ln is equals to 0. And what is the definition that we had? For all epsilon greater than 0, this is the limit definition. There exists m belongs to z plus such that, I hope you remember the definition of the limit. Next, just taking this one, what is that? Un minus ln is strictly less than epsilon, like you'll be having mod. So if you take u, what is un? UPF, UPF or UFP minus LFP, which is less than epsilon. What is u minus f? F. F belongs to R over a comma b. If f is a Riemann integral with respect to integrals, what is the condition that we have? A bar to b is equals to a to b bar is equals to a to b, right? And then now you will be having, we know that fp, look into this step. Here you will be taking, we know that LFP is less than or equals to the lower integral, and UFP is greater than or equals to the upper integral. So just write ln and un, and there will be a relation between these both. What is that? Ln is less than integral f, which is less than or equals to un, right? Why? Because we got from this, like from this step, UPF and LPF. Now subtracting ln on both sides. So how will you write? Ln minus ln is less than or equals to a to b f or f minus ln, like we are just subtracting everything, ln on all the sides, un minus ln, right? So this is ln minus ln is however 0. This is less than or equals to integral a to b f minus ln. This is less than or equals to un minus ln. Now put limit on all the sides. If you put limit, like you have to put limit on all the sides. If you put limit, what is that? You'll have 0 less than or equals to integral f minus limit ln, and this also will be equals to 0, right? Un minus limit ln also will be equals to 0. This is 0, this is 0. So what is that? We can conclude integral a to b f minus limit ln is equals to 0. So what will be limit ln? Limit ln is equals to integral a to b f of x dx. Now what is that we got to do? We got to subtract un. Till now we have did with ln. Now you got to subtract un and then apply the limits. If you apply the limits, what is that you'll have? In the same way, how did you do ln? In the same way you got to do un also. So after you do un and ln, this is what you'll be ending up. That is a to b f of x dx is equals to limit un is equals to limit ln. What is n? That is limit n tends to infinity. Now moving on to the next theorem, that is let f be a function defined on closed interval a comma b and c is lying between a and b, and f is integrable on closed interval a comma b and on c comma b. That is like f is both closed on ac and cb. Now they are asking us to prove f is integrable and integrations of these are equal. So first, what is that you have to do? Given that it is bounded and it is also integrable, where on these two intervals, right? So given that, what is that they gave? F belongs to R over A comma B. Then for all epsilon greater than 0, there exists a partition. You got to write Riemann integrals definition. What is that? UPF minus LPF or UFP minus LFP. Next, given that f belongs to R over A comma B, obviously here also there exists some partition P2. So we are taking P1 and P2. So what is that? What is P actually? Union of P1 and P2. So UPF is equals to P1 plus P2, right? And now next you got to, like, there is equation 3 and equation 4. You got to subtract from that. So what is that? You'll have, see, UPF minus LPF is equals to, what is UPF? UP1 plus UFP2. What is LFP1 plus LFP2? So now just write these positive, like FP1 one side and P2 one side. So what is this? This is strictly less than epsilon by 2. What is this? Even this is also less than epsilon by 2. So epsilon by 2 plus epsilon by 2 gives you 2 epsilon by 2. 2 gets cancelled. This is strictly less than epsilon. So that is what you got over here. Now coming to, like, the first one, the first condition which we actually wanted to prove is completed. What is that? This one. F is integrable on AB. Now we have to prove the second condition. So to prove the second condition, what is that we know? What is that we have to make use of? The UPFs and minus LPFs. I've already told all these while I was explaining the definition. So just be careful and study the definitions properly. So from these two, you can put a link. That is how integral a bar to b is equals to integral a to b bar is equals to integral whole integral ab. So instead of these integral a to b bar or a bar to b, put integral a to b. So LPF is less than or equals to integral a to b f of x is less than or equals to UPF. Okay, till here it is finished. Now, what is UPF? UPF lies between integral a to b f and integral, like, UPF is integral a to b f less than or equals to u f comma p. So how will you write this? What is UPF? UFP1 plus UFP2, this one. And obviously u is less than or equals to L. So that is what we wrote. So LFP1 plus LFP2 plus epsilon. Next, this is what you'll get. That is integral a to b, integral a to c, and integral c to b plus epsilon. Next, you have to look into LPF. What is that? Integral a to b, which is greater than or equals to LFP. So integral a to b greater than or equals to LFP1 plus LFP2 minus epsilon. So when you add these 6 and 7, or from these sixth one, that is this one and this one, what is that you'll get from 6 and 7? See, this one. You'll get this equation. When you solve, you will be having a to b f is equals to a to cf plus C to be F. Okay, I think I'm clear till here. Next, moving on to the next theorem. This is very easy. If you know the formula of UPF and LPF, you will be able to solve this question. The last theorem in this unit is this one. So what is that they asked? If F is bounded function on closed interval AB, and if P and Q are partitions of closed interval AB, then they're asking us to prove LPF, which is less than or equals to UPF. So how is that you will prove? P and Q are two partitions, then take partitions, then union of partitions will also be a partition, then define Q and define P. What will be P union Q? All these terms, like combine all these terms and write it in P union Q. So P is subset or equals to P union Q. So what is that you'll write? LPF or LFP, which is less than or equals to, instead of P, you will be putting P union Q. So L P union Q, P union Q comma F. This is less than or equals to U P union Q comma F. So something like P, F or P, P or F, both are same. So you will be getting this step. Which one? This one. So in the same way, if you do for Q, you will be getting this step. Combine this 1 and 2, what is that you'll get? LFP is less than or equals to UFP. I think I'm clear till here. Whatever doubts you have, you can put it in the description box or the comment section below. Thank you so much for watching this video. Please do subscribe to my channel.